Hello, we are in Chapter 7, Section 7.1, Composing Functions. In this video, we're gonna go over problem number 2, in which we are given 3 different functions to find different compositions. This time, we'll be actually finding the formulas for those compositions, maybe in simplified form, if we will be able to do it. The first one is f of g of x. Second one is g of f of x, and the third one is h of g of x. So whenever we try to find compositions, it's important to understand which function is applied to the input and what that input is first. And in part A, the first function applied is the function g. So we simply need to know what g of x is, and we know that g of x is x minus 3. So we will be evaluating f at x minus 3. So to be able to do it, we want to know what f does to any input, whether it's just a single variable, a single number, or if it's a more complicated algebraic expression like that x minus 3, that we have in here that becomes the input of f in this step. So we want to see that function and eventually all the functions in the form that is free of variable labels. We want to understand what the given function does to its input. So let's see what it is for the 3 functions in here. So what f does is it squares the input, then takes the opposite of it, takes away 5 times that input. G takes the input and subtracts 3 from it, very simple. While h first adds 2 to the input and then takes the square root of that. So we are now evaluating f at the expression x minus 3, so that x minus 3 becomes our input. And we'll just have to write it all down. So it's -1 multiplied by the square of that quantity x minus 3 minus 5 times that quantity x minus 3. So it's very important that we use parentheses in here. And that's gonna be it. We just need to expand, combine like terms to simplify. So let's start with squaring x minus 3. To remind you, to square means to multiply the base by itself. So here we multiply x minus 3 by itself. We can use foiling for that purpose. So we get x squared, then minus 3x minus another 3x, so that's minus 6x, and then plus 9. And that's gonna be multiplied by this external factor of -1. So we're gonna have minus x squared plus 6x and minus 9. Now the second part, minus 5 times the quantity x minus 3, we just have to distribute that -5 in that difference, so we're gonna have minus 5x and then plus 15. So now we just combine like terms. There is only one second degree term, so it's gonna be minus x squared. Then for the first degree terms, we have plus 6x and minus 5x, so that's plus a single x. And finally, the numbers are minus 9 plus 15. 15 minus 9 is 6, so it's gonna be plus 6. And that's it for part A. In part B, we are finding g of f of x. So now f of x is the first function applied, and we will just be evaluating g at f of x. So we just throw that f of x inside here, and f of x is minus x squared minus 5x, and that will become the input of that external function g. So if we are evaluating the function g, we have to throw the input into that function. That input is minus x squared minus 5x. So that's what needs to go here for the input and there. And remember, g takes away 3 from its input, so it's fairly simple. It's just gonna be that input minus x squared minus 5x and then take away 3 from it. That's what we did in here. And now it's just a matter of simplifying, but we acknowledge that there is really nothing to simplify because there are no like terms to combine. That's simply it. And finally, in part C, we are evaluating h of g of x. So g of x is the first one, and g of x is x minus 3. So inside those parentheses, we're going to have x minus 3, and to that we will apply the function h. So now we are plugging x minus 3 as the input for the function h. So here I will fit it, x minus 3, x minus 3. So that's going to be the square root of that quantity x minus 3 and then add 2. We can simplify, of course, what we have under the square root. Negative 3 plus 2 is negative 1, so it's really going to be the square root of x minus 1. And we are not able to simplify it any further. That's going to be the final answer for part C. So these are the corresponding answers for each part.